systematic error that is usually accompanied with our variables. Now, what is a systematic error? We have already seen that there are specific patterns to systematic error in our data. One of the most common uh, artifact or one of the most common sources of systematic error is what we call as the common method bias. Now, what is a common method bias? Common method bias occurs when you have a common source responding to all the questions of your survey, right? So, for example, in this case, in this data that we had one person responding to leadership, then also responding to procedural justice items, and then also responding to the creativity items, right? So there is a common source. So common source is, we usually use this interchangeably. It is a kind of a method problem, right? So we have collected data on leadership, it's 10 items, okay? And uh, procedural justice, creativity, and we were testing these paths between these constructs. Now, what we have to do in order to actually test, either you test or factor for common method bias, either you explicitly also collect data on a particular construct. So, for example, social desirability. So there are scales for social desirability. You uh, collect data on social desirability, and then you load, you factor in. So all these items that were there for leadership, okay, what is done is, and there were 4 items for procedural justice, and there were items for creativity, okay. Let me just erase this to make it a little better. Okay, so we have these items, okay, and here also let me make this more realistic, what we are having in our data. Okay, so we had 3 first order factors, and EMP had 3 items. Then we had task orientation, it had 4 items, and then we had LEX, which had 3 items. Okay, so what is done is that you model this common factor, you model this common uh, construct, which is like a social, it's like you can measure social desirability, and then each item is also loaded on, along with the factor, each item is also loaded on this construct, right? That means now you have one more source impacting. So each item, so this particular item, for example, here, this particular item, this is I10. I10 is getting impacted by measurement error, by LEX, and also social desirability. So the response on this item is not just because leading by example, but it is also because of the social desirability. That person is trying to be desirable, trying to be politically correct, right? When that person is responding on that item. So each and every item, because social design, this is a problem, this is a characteristic inherent to the individual. Therefore, this bias is going to be systematically impacting all the items that this person is responding, right? So we have this is called as modeling the common factor, right? So you can either estimate it through the social desirability or some common construct. The best example is the social desirability, and we also constrain all these paths to be equal, right? So all these paths are actually constrained to be equal. So we say, well, we will apply the loading A, right? That means all these paths will have a loading of A to the A in this case, right? So because it is social desirability, so it is impacting all these items in a similar manner. So the loadings of each of these paths is going to be the same, right? So we constrain that. After modeling this, now I report what happens to my paths between the three constructs. So what happens to my beta 1, what happens to beta 2, what happens to beta 3. If you can show in your research that after accounting for this common factor, the paths are still significant, right? That means the beta 1, beta 2, and beta 3 are still significant. Then it shows that your model, that while there may be some problem of common method, but it is not significant enough to actually impact the or relationships in the study. So that is what you want to prove in this case. In case you do not have a social desirability construct, you can also model a common factor model. So you without any indicator, so we call it as the common method. And the same thing is done. You model it, and the same way, without an indicator, you actually load this common factor. You have path from this common factor on all these items, right? So though in research today, in literature today, it is advisable that you try and model this kind measure. You collect data on this kind of a construct. So examples of these are, you can collect data on social desirability or emotions, positive or negative emotions, right? Negative, positive emotions, and then you measure, you sort of model the measurement of this common factor and then load it. In case you have not collected such a data, you can also model this latent common method factor, and then do the analysis. So I'm going to demonstrate how would you work with the common method factor in this example that we were working on. The otherwise the measurement, the way you would do it either with common method or with social desirability will not change. Here I'm going to demonstrate with a common method factor for our analysis. So let us do it. Okay, so we will go to Amos. Okay, and this was our model. This is the model that we were working on. Now what we will do is we will model a common method factor. Okay, so we will model this common method factor. We will call it as, let us give it a name, common method. let me give a smaller name, common, or let me just call it as same, common method. Now what I'm going to do is, as I mentioned, we will draw a path from this factor to each of these items, because this factor impacts my response on each of these items, because I am the person who has responded to all of these. I'm going to have a path from this latent factor to each of these items. Now I will beautify it. Okay, so this is my thing. Okay, and then I am going to select each one of these paths. And I'm going to constrain them to 1. Okay, and select this also. Okay, and then you will see drag properties. Here, constrain. Yeah. So we'll just write these names. We are applying this constraint to all these paths now. The same constraint, that means the loadings are going to be the same. I give it a name A. And now because ideally, because this is a latent factor, one of the paths I should have constrained to 1 in order to make this identified. If you don't make any one of these paths to 1, because I don't want to make it 1 because I have applied a constraint A. So what you need to do is you need to define the variance of this model as 1. In case you do not assign a value of 1 to these paths, the other way to actually make this model work or make this factor identified is you need to set the variance as 1. Setting the variance 1 means that this factor is now a standardized factor. That means it is now standardized, its variance is 1. Variance of a standardized variable is 1. So it is a standardized factor. Okay. And this is now, therefore, I don't need to apply a unity constraint to these, any one of these paths. There are two ways to assign a metric to a latent factor. Either you assign a constraint of 1 to any one of these paths, or you set the variance of this latent factor to be 1. In this case, I have not assigned a unity constraint to this path, so I am going to set the variance of this factor as 1. Let me just check again if I have applied the constraint to all of these A, A, A. Yes, this is correct, right? Okay, now we will save this and now we run our analysis. Okay, so yes, it is. We don't need to model. We are not saying because this is a common method factor, it does not co-vary. So we will leave it without, we don't need to model the covariance and we will run this analysis. The model fit is not bad. It is chi-square by df is fine. GFI, CFI, RMSEA, they are all okay. No issues with this. Now we go to estimates. Okay. Now, what we see here is after we have brought in this common method factor, so we see that the loading of the common method factor on all these, this is the same because we had kept it. So it is 0.284. Okay. So 284 is the 0.284 is the loading and it is the same on all the paths. Now, after bringing in this common method factor, what happens? Leadership to procedural justice, it is significant. That means this leadership has an impact on procedural fairness. It is significant. Then leadership on creativity, well, it is now reduced. It is now significant only at 10%. That means there is, after you have modeled the common method, this relationship has weakened. It is still significant, but at 10% only now. And the last one, procedural justice to creativity, you see this relationship has gone from being significant to non-significant. That means what? After you model this common method factor, what happens is that this path is no more significant. That means this path was actually coming out to be significant, maybe because of the systematic bias, systematic, because the same person has responded on procedural fairness and creative behavior. Now this path is no more significant. If you can show after your analysis this path continues to remain significant, then it is a stronger support of your relationship that, and you should write it in your research paper, that we did model a common method factor, and even after doing that, we have got a significant relationship between our construct, and these are the standardized values, right? So we have now modeled this common method factor and it is showing that our relationships change from being significant to non-significant. Some of them remain significant, but at least one relationship becomes non-significant.